Well, in this short video, we're going to wrap up our discussion about inverse functions. And let's look at a couple of facts here. Number one is, this is a fact. Given an invertible function f, this ordered pair is on the graph of f if and only if what is on the graph of f inverse? Well, we saw this in the previous video. You switch the components. y1, comma x1. Switch the components and you go from the graph of f and you move over to the graph of f inverse. Here, the graph of f inverse is the reflection, like a mirror image, of the graph of f about the line y equals x, the line that goes through the origin and has a slope of 1. It's like that 45-degree angle. Okay, example. I've given you a graph here with a function f. And what I want is to graph f inverse. All I need to know is, and this is the line y equals x right here. So all I need to do, I'm going to angle this a little bit, is use that to be my mirror. So I'm going to graph it as best I can here. I'm not a good artist. Let's see. I have to go out like this. And then like something like this. So what I tried to do here, that's not too bad, is make a mirror image of the graph f. This is f, and the one I just drew is f inverse. You can just flip it over, this line y equals x. So that's nice. If you have the graph of an invertible function f, it's easy to graph the inverse function. Oops. Okay, so let's do one more like this, where we probably didn't do this example, but you probably won't be surprised to know that y equals x cubed, so it cubes, f of x, you could think of y as being f of x. F of x equals x cubed. It means it cubes, or raises to the third power, anything you plug in. Well, this function, say it were g of x equals the cube root of x, it takes the cube root of anything you plug in. So you can imagine that they are inverse functions, and we're going to graph them on the same plane. I should have put some graph paper here, but I'm going to do my best. Make an xy plane like that. And let's see, if that's the origin, I know I have to graph 1, 1, 1. Because if x is a 1, 1 cubed is a 1. So that gives me that point there. And then at 2, it jumps all the way up to 8. So I'm going to put it way up there. So it's going to look something like, and if you plug in a negative 1 for x, you get a negative 1 for y. So it will look something like this. I'm going to call that y equals x cubed. It's certainly not perfect. Best I could do without graph paper. And the other one is the cube root of x. Well, the cube root of x still has this point, has 0, 0 on it, because if you plug in a 0, y is a 0. If you plug in a 1, y is a 1. So it goes like this. And then out like that. And then also negative 1 works. The cube root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 is negative 1. So now I'm doing that, so it's going to be like this. Okay, that's the best I could do. Y equals the cube root of x. And notice that they are mirror images of the line y equals x, which I'm going to draw here. So, sorry about that graph. Do the best you can on that one.